Welcome to another Intermediate Algebra video. In this video, we'll start to look at simplifying, multiplying, and dividing rational expressions. Okay, which leads us to our one and only objective, which is exactly that: simplify, multiply, and divide rational expressions. We looked at how to factor, and factoring will be a method that we use in order to do this. So here are some steps. Oh boy, stand underneath them. Some steps on how to simplify. Simplify and multiply have exactly the same steps. So the first step is to completely factor the numerator or numerators, if there's more than one, if we're multiplying, and denominators, and then divide out the common factors to the numerators and denominators, aka cancel. We use the word cancel a lot of different ways. In this section, it means to divide out the common factors to the top and bottom. And if we have a problem that asks us to divide, then we will first use the trick of keep, change, flip. Keep the first. You'll see it noted like this. Keep, change, flip. We'll keep the first fraction the same, change the operation from division to multiplication, and then flip the second fraction upside down, and then we'll follow the steps for multiplying. If we use keep, change, flip, we change it to a multiply problem. And then we can factor and divide out common factors. The majority of our work in this section will be the factoring. All right, first example. Okay, so the first one asks us to, actually the directions for all of these will say simplify. Okay, so if we're going to simplify, we want to factor the numerator and denominator, and then look if there's anything in common that we can divide out or cancel out. So our numerator first, 2x squared. There's only one term, so there's nothing we can do to factor that. Then our denominator, 10x cubed minus 2x squared. Remember, the first thing we always look for when factoring is a greatest common factor. And we can see that these terms have a 2 and 2 x's, so an x squared in common. To factor with a GCF, take that item and pull it out of each term or divide it out of each term. That leaves us with 5x and then minus 1. In order for this to represent the same thing, we need that placeholder of 1 in order for it to distribute and go back to the first line that we started with. Okay, so we have completely factored numerator and denominator. There's nothing else we can do with the 5x minus 1. It's always possible, but in this case, there's nothing else we can do. So then step 2 is to divide out the items that the numerator and denominator have in common. So we can see that our numerator has a 2 and our denominator has a 2. And we also have an x squared on top and bottom. Imagine 2 x's on top, 2 x's on the bottom, they both cancel out. So that leaves us with 5x minus 1, but where is that 5x minus 1 located? It's in the denominator, and so it needs to stay in the denominator. What's left in the numerator? Well, we took out the 2, we took out the x squared, but if we divided those items out, if you divide 2 from 2, we're left with 1. So whenever everything disappears from a dividing out cancel, you're left with a placeholder of 1. So this is what this problem simplifies to be. All right, our second problem is a multiplication problem. We have 1 plus 3n all over 2n times the quantity 2n minus 4 over 3n squared minus 2n minus 1. It's very tempting to say, hey, well, I see a 2n and a 2n and cancel those out. But we can't do that. You can only divide things out when they're being multiplied. So when everything's multiplication, you can divide to undo it. In order for this to all say different things being multiplied, we need to factor. So start with our first numerator, 1 plus 3n. First thing we look for is a greatest common factor. 1, 3n, we don't have that. Then we check if we can use sum or difference of cubes or difference of squares. We don't have that here. So our numerator is, oops, that's erased still. There we go. Our numerator is as factored as it will get. Our first denominator, 2n, it's one term, so there's nothing we can do to factor that. this is being multiplied by this numerator, 2n minus 4. First look for our greatest common factor. You can take a 2 out of that, leaving you with an n minus 2. And there's nothing else we can do with the n minus 2, so that's fully factored. Then in the denominator, we have 3n squared minus 2n minus 1. First look for our greatest common factor. We don't have one, so we can use our 3-term method of AC. Remember, this is where you multiply 3 times negative 1, A times C. This gives us negative 3. We want two things that will multiply and give us negative 3 and combine, add, subtract to give us negative 2. Well, the only things that multiply to give us negative 3 are 1 and 3. And in order to get a negative, it has to be 1 negative, 1 positive. So these are our two options. To get negative 2, that middle term, we need positive 1 and negative 3. So take the middle term, break it apart into plus 1n minus 3n. Now, if you reverse the terms, that's okay. If you wrote minus 3n plus 1n, completely fine. Then continue on with factoring by grouping. This is part of the AC method. The first two terms have an n in common. Take that out. You're left with 3n plus 1. The last two terms don't have anything in common, but we want it to say something times the quantity 3n plus 1. So we choose to take out a negative 1, which would leave us with positive 3n and positive 1. Finish up the factoring. They have a 3n plus 1 in common and minus 1 left over. So the fully factored denominator, 3n plus 1, n minus 1. Okay, now we look for things to divide out or cancel. Do we have anything the same top and bottom that we can get rid of? The first thing you might notice is the 1 plus 3n. This you can look at as having parentheses. It's the numerator. It's a package deal. You can look at this as one item and compare it to 3n plus 1. If I reorder the terms in 3n plus 1, they're both positive. I have 1 plus 3n, which is exactly what we have in the numerator. So those can cancel out. Anything else? Well, we definitely can't do anything with the n minus 2. We would need package deal n minus 2 in the bottom, and we don't have that. But what about the 2? I don't see a 2 on its own in the denominator, but I do see a 2 multiplying an n. You can most definitely separate when it's multiplication like this. 2n is the same as 2 times n, which means we can cancel out these 2's and then just write everything that we're left with. So in the numerator, we have n minus 2. In the denominator, n times the quantity n minus 1. If you distribute this n into the denominator, perfectly fine. An online homework system should accept both. On a test, I would accept both, but I often see this is a place where mistakes happen. When you try to distribute that back in, you don't have to. It can stay just like this. Okay, so there is a simplify problem, and the directions are still simplify, but this was a multiplication problem. Now let's look at a division problem. Division. 8m squared over 3m squared minus 12 divided by 40 over m minus 2. So the first thing we can do with a division problem in order to simplify it, that's still ultimately what our goal is to simplify. First thing we can do is a modification. Use keep, change, flip to change this to multiplication. So keep, change, flip. Keep the first fraction the same. 8m squared over 3m squared minus 12. Change the division to multiplication and flip the second fraction. M minus 2 over 40. Okay, now this problem doesn't look any different than the type of problem we just did, a multiplication problem. So, factor, and then cancel out or divide out what they have in common, top and bottom. In the numerator, first numerator, 8m squared, it's one term, so there's nothing we can do to factor it. In the denominator, we have 3m squared minus 12. The first thing we can do with this is the greatest common factor. Take out the 3, then we're left with m squared minus 4. Continue checking. We have two terms. Can we use sum difference of cubes? No. Can we use difference of squares? Yes. We have m squared with subtraction and 4, which is something squared, 2 squared. So this factors to 3 times the quantity, m minus 2 times the quantity, m plus 2. Those orders can be reversed. Okay, our second numerator, m minus 2. Nothing we can do to factor this. And our denominator of 40, one term, nothing we can do with it. Okay, so we've fully factored. Now we look at dividing things out. Things that have in common top and bottom. All right, so what do you notice right off the bat? Maybe something jumps out to you more than others. The first thing that would jump out at me would definitely be an m minus 2. I can see that I have that exact factor top and bottom, so that cancels out. Then the only stuff that's left in the numerator for me to check is an 8 and an m squared. Well, the 8, I don't see an 8 exactly in the denominator, but I can simplify with 40. If I have 8 over 40, what does this simplify to? Maybe it takes you a few steps to get there. That's okay. Cut it in half. We have 4 over 20. Cut it in half again. We have 2 over 10. Again, we have 1 over 5. Maybe you got to 1 over 5 right away. Maybe you noticed they both have an 8 in common. Divide that out right away. That's fine. So ultimately, we get to a 1 being left here, and you really don't have to write the 1, and a 5 in the denominator, but that should be written. Okay, the only other potential item that can go away from the top and bottom is m squared. All that's left in the bottom is 3 and m plus 2. And this m plus 2 is a package deal, so there's nothing else you can do with it. So that takes us to our answer. What we have left in the top is a 1m squared. You don't need to write the 1 if there's something else. And in the bottom, we have 3, and a 5, and m plus 2. And you would be expected to multiply the two numbers together. You would be expected to multiply 3 times 5. That may feel confusing because I said that you don't have to distribute the number, but if they're the same thing, if it's a number, that's the kind of simplification we're looking for. The same reason that we would divide out an 8 from here and get 1 over 5, it's the same type of reason. We need to multiply the 3 and 5. So this would be your final answer. And again, not wrong if you distribute the 15. That's also okay. Something that is a big part of these problems is the factoring. So if you're feeling lost along the way and you're not sure why, there's a good chance that it's because of the factoring. Remember, that's a huge piece of everything that we're going to do in this unit. So make sure you either go back and watch the video on factoring, find some extra outside sources for help with factoring, but you will need to have the skill set of factoring. And it doesn't go away. When you move on to college algebra, factoring is still a prominent thing, something you're expected to do to solve any certain type of problem. All right, so we saw a simplify problem, a multiply problem, and a divide problem. Let's go ahead and practice. Pause the video, factor each numerator, each denominator, see if anything cancels out top and bottom, and then write your simplified answer. Come back whenever you're ready and we'll go through it together. Okay, let's take a look at this one. You've gone through, you know what answer you got. Let's see if we got the same thing. So our first numerator, first there's no greatest common factor, but we can use difference of cubes here. So the first numerator factors 2x minus 1 times the quantity x squared plus 1 times x, which is just x, plus 1 squared, which is 1. Our first denominator has a 3 as a GCF. You can take out 3 or negative 3. I'm just going to take out 3, leaving me with negative x plus 1 times. Our second numerator has 15x squared. That's only one term, so there's nothing we can do with that. And the denominator, x squared plus x plus 1. It's a 3 term and there's no GCF. So let's try AC on it. That would be 1 times 1. So we're looking for 2 things to multiply and give me 1, and add subtract to give me 1 in the middle. Well, the only 2 things that multiply and give you positive 1 are either positive 1, or negative 1 and negative 1. These combine to be 2, which is not what we want. These combine to be negative 2, which is not what we want. If that happens, it means this does not factor. Just like some 2-term polynomials won't factor, this one might also not factor. All right, we have fully factored. Now we look for things to cancel top and bottom. The first thing that jumps out to me is this factor of x squared plus x plus 1. Same top and bottom, that's gone. Might also jump out at you that this 3 and 15 can simplify. That would leave us with 1 on the bottom. Write it, don't write it. And for the 15, we have a 5. So the only stuff left is this x squared, and there's no individual x's on the bottom, so nothing will happen there, and this x minus 1 quantity. If I compare these two, x minus 1 and negative x plus 1, they're close, but their signs are wrong. So we use the same type of trick that we use in the AC method. We can factor out a negative 1 from this, and that would give us x minus 1. Imagine if you redistribute that negative 1 back into the parentheses, you'll have negative x plus 1. So you know this is an okay thing to do. And then we do have the same factor top and bottom. This only works when every single sign is wrong. In this case, both signs were the complete opposite. If it's just one of them, it won't work. Okay, so all that's left in the numerator is an x squared, and the 5. And in the denominator, we have a negative 1, and well, that's gone because we used it. That's it. So this ultimately simplifies down to negative 5 x squared. 5 divided by negative 1, negative 5. Who would ever think all of this crazy looking rational expression could simplify down to one single term? Okay, so we saw simplify, we saw a multiply, we saw a divide problem, and ultimately they all kind of feel the same way. The directions most likely will just say simplify, and so this is something that we'll use as kind of a last step for a lot of the problems that we do in the rest of this video, or in the rest of this unit. I'll see you soon.